This is a free body diagram from this John Deere excavator. So we can see that the 10,000 pound force coming from this way, or in other words, to dig in this place, it was assumed that it's gonna take about that much amount of force. Then the what is the required cylinder force? So what we can do here is let me use another color pen. So this is about 45 degree and that's 15 degrees, so that's 60, so that will be then 30 degree. So we can resolve this force, cylinder force, this way: F cylinder cosine 30 degree, and then this way it will be this word force F sine 30 degree, cylinder sine 30 degree, or you can write cosine 60 degree, same. Now we need to take the moment with respect to this pivot point. So let me make this a little bit bigger so I can. So if we take moments with respect to this pivot point, moment anti-clockwise moment with respect to the pivot point, all moment is equal to 0. Then for this 10,000 pounds, it's going to do a clockwise moment, which is minus 10,000 times the distance 12 inches, and this is in pound. And then this cylinder will do an anti-clockwise, which is positive. F cylinder sine 30 degree and times the distance 1 inch, and this is equal to 0. So if we solve for the cylinder force, F cylinder, it's gonna be 12 10,000 times 12 inches, 10,000 pounds times 12 inches, divided by sine 30. So it's gonna be 10,000 times 12 divided by 30 sine. So I got 24,000 pound force, like that. So that is the cylinder force developed, which is actually asked you to calculate here. So cylinder force F cylinder was calculated 24,2400 or 240 kips. Now it says what class of lever is that? That's a first class lever. Check the other videos for that. So first class lever. And then is this lever shown within the circle of the excavator mechanically advantageous or disadvantageous? First class lever does not have any advantage or disadvantage. It's a neutral lever, so no advantage or disadvantage. It's a neutral lever. What is the economic advantage of using this lever system shown within the circle of the excavator? If the hydraulic system is expensive, or sometimes it's maybe the packaging of how you want to do. Primarily it's the packaging that kind of don't allow for use to mechanical levers. So the economic advantage would be the packaging of the system. You have enough strong hydraulic system. You really don't. If you have a weak hydraulic system, you probably can use some mechanical lever advantage. But if you don't have any other information, you could just simply say it's the packaging. But if the system has to develop more load, which is not possible, then you can use some other type of maybe a second class lever to get the mechanical advantage. Now let's calculate the pressure, and then we'll kind of go back to this question later. So pressure is force times distance, area. So force is 24000 divided by 10 inches square pound. So this is 224,000 psi, which is actually huge pressure. Some materials even go to yield at this 24 ksi. So it's a quite high pressure. So it could be, the economic advantage question here, a second club lever would be advantageous, but because of the packaging, it's not possible to use that package. Comment on the pressure, huge pressure. It will be difficult to design the cylinder like that. Difficult to design cylinders. Also pumps that produces that much pressure. If the system delivers 20 gallons per minute at the blank end of the cylinder of the lever system shown, calculate the power of the system. So the power that is the cylinder is carrying can be calculated as PQ by 1714. So that would be 24,000 psi times 20 gallon per minute divided by 1714. So that would be times 20 divided by 1714. That is 2800 horsepower, which is a ridiculously high, powerful system.